Hello students, and welcome to the first lecture or introduction of the mechanics of materials. For this course you need to have a prerequisite of statics course, which is a part of engineering mechanics, and the second part was dynamics. In this case we are gonna not talk about the dynamics, so it will be all about the statics. For statics we had the condition of equilibrium, that the forces must be equal to zero, the net moment must be equal to zero, and then we split them into 2D and 3D problems. For 2D, the forces in x and y would be 0, and the moment about a certain point would be 0. For 3D, you have an extra z-axis in both the cases, and this was the main condition for the equilibrium in which we dealt it in the statics part. In the statics, we also talked about the body, which is a rigid body, which means it is non-deformable. So all the forces that would be applied on the body, we would analyze the forces, we would talk about the components of forces, we would talk about the resultant of forces, but we never talk about what happens to the body. The body was not deformable, it was rigid. All right, but in reality it does not exist like that. So the body gets impacted by the applied forces, so its shape changes, it either deforms in a certain way or it breaks. Okay, so it gets a failure, or it is only deformed in a certain way. So that is actually our realistic deformable bodies that we are going to talk about in the mechanics of materials course. Okay, and we are going to talk about how the material behave under certain loading. All right, so this is what is the difference between the statics and the mechanics of materials. For example, if you look at this case, so there are actually 50 Newton force applied on the body, and it results in a certain crack. Okay, this is a failure. Now the body has a cross-section area, let's say A1. Okay, now there is a second body where the cross-section area is now larger, A2. Okay, and similar forces are applied. Now you have a question that will the second shaft also fail? Will it fail? Okay, so again it will depend on your cross-section area. Now your cross-section area is actually increased. Okay, and your force is again constant, it is the same 50 kilonewton applied. That would mean that the stress in the body is reduced because you are increasing the denominator. So when the denominator increases, your applied stress reduces. So it is very much possible that this shaft will sustain and it will not break like the previous shaft, or if it breaks, it will be able to sustain larger forces than the previous one. Okay, so this is what we are going to discuss. In this case we found out the first thing that the deformation actually depend on the stresses in the body. Okay, so it is not only force, it is also the cross section area. Secondly, if you look at the second case where we have two different chopsticks, so this is chopstick 1, then you have chopsticks 2. In this case, in the one you are trying to twist, so you are actually trying to twist the chopsticks. Okay, and what we get is applying a moment, something like this shown here. Okay, so what these moments would do is, it's very possible that it will actually split up your chopstick. Okay, in second case you are trying to bend it, so you are applying some forces like this. You are not trying to, or you are applying a moment in a different way. Okay, you are trying to bend it in this way. So in that case what you are doing is actually you are trying to bend it, and it's very possible that it will not peel off, but it will create some fracture or break at this specific point. Okay, so for the question, will the material behave similarly? No, it's a common sense. If you are twisting it, it will be different behavior than when you are trying to bend it. Okay, so the deformation and failure of a body will depend on where and how the forces and moments are applied. Okay, so in this case both are moments, but they are applied in a different way, so the how is different for each case, and that's why their behavior will already be different. Okay, for example, if you look at the case of bending, you are trying to get this bending, and it will give you a bend something like this given here. Okay, and that is because of these two moments applied at both the edges. Now you see that this is the forces are applied at these specific points, okay, that is creating actually these two moments. But what happens is it's very possible that your body will fracture at this specific location, okay, at the central point. So it is not the forces or the applied external loading that is creating the deformation and failure. It is as a result of this moment there are stresses induced throughout these chopsticks, okay, and those stresses are actually the ones responsible for the behavior. So that's why we say deformation and failure occurs due to the internal reaction stresses. Okay, internal reaction stress is very important word. So the deformation and failure occurs not because of directly because of your applied moments or forces. It is because of the reaction that is produced within the chopstick, okay, and those are the internal reaction stresses. All right, so that occurs because of those internal stresses rather than external moments. Okay, in this course we are going to talk about the external loadings, what are the different kind of loadings or forces that can be applied, and the result of those loadings would be creating stresses within the body. Okay, so we are also going to look at what kind of internal reaction or stresses, specifically this one, what kind of stresses are there. So there would be a normal stress, there will be shear stress. I don't know if you have heard the names before. There would be normal, you have a tensile and compressive stresses, okay, but these are the stresses which are the produced or the internal reaction that are produced because of the external loadings, okay, and these stresses actually what it does is they deform the body, they change the shape of the body, okay, and in some cases it can create the material failure as well, okay. So you have forces applied, and then as a result of that what you get is stresses produced. For example, let's say this is a normal stress sigma produced in the body, and that would be equal to your, let's say if this is the cross section area, so your stress will be equal to the force divided by the cross section area. That is what the normal stress will be produced, but this will not be the only stress, there will be shear stresses produced in the body as well. So we are going to talk about the loading types, the forces that are applied, and we are also going to talk about the internal stresses produced, that will be internal reaction, and then how the body will behave. So what would be the deformation caused, and if it is failing, so at what point it is going to fail. Okay, so these are certain topics that we are going to cover. So starting with the mechanical behavior of ductile and brittle materials, okay, and then we did talk about the internal loading, so it would be like tensile, compressive, torsional, combined loading, and then failure analysis, material properties, so that would be depending on certain materials. Factor of safety is very important because if we are deploying a material for a certain task, we need to know what is the factor of safety for that material at that specific task. Otherwise we might get a failure for that material and that material might break. Some standard testing methods, so we have impact testing, and then we have these three hardness testing of the materials, and we also have this fatigue analysis or cyclic loading, and then bending failure and more circle. So these are different techniques that we can use to actually check the reaction of the material based on the applied loadings. Okay, and then at the end we should be able to predict the size change, the shape change, and the bending produced in the part in different parts when certain forces are applied. So that would be when we know the material properties. Like for example, if we know the material properties, we know the forces, we should be able to know that what would be the result of that body, or how the body will respond to those forces. Okay, so that would be the last thing that we do in this course. All right, I think this is good enough for the introduction, and I'll see you in the next video. We are gonna go deep into it. All right, thank you very much, take care, goodbye.